Okay, so diluting solutions. So diluting solutions, basically what you're doing is you're taking a high concentration solution, and then you're diluting it with more water to make a less concentrated solution. And there's a couple different ways that this be can be attacked, or different directions you can take this from. However, you're always using the same formula. You're always using the same kind of formula here. And that formula is M1 V1 equals M2 V2. Okay, that's a V. Okay, and M stands for molarity. And V is volume. And just to be safe, we always want to use our volume in liters. It's just easier to do it always in liters. It kind of works if you keep it in milliliters the whole time, but I rather just use liters. Uh, Better safe than sorry. Better safe than sorry. Okay, so again, this is the formula we're almost always going to use for diluting solutions. Sorry for this pen is acting up. It's not letting me write very neatly. Okay, so basically you start with, so this is the first solution, the molarity of the first solution times the volume of the first solution equals the molarity of the second solution times the volume of the second solution. Okay, let me give you an example of a problem. Let me give you an example of a problem. If you take 15 milliliters, so 15 milliliters of a 5 molar solution, and we dilute it, so 15 milliliters of a 5 molar solution is diluted to a new volume, so to, let's say, 500 milliliters. What is the molarity of the new solution? So this is the kind of like the simplest, most basic kind of question that may be asked of you. So we have our original molarity is, this is our M1, our 15 milliliters. That's our V1, but we want to convert it to liters. So this is 0.015 liters. Sorry, again, my pen is acting up. Okay, that's our V1. Yeah, and now our V2 is this 500 milliliters. But again, we have to convert that to liters, so it's 0.5 liters. So 0.5 liters. Okay, so we're just going to plug that into our formula. So M1 is 5, V1 0.015. Our M2 is what we're trying to find. Our V2 is 0.5. Okay, so we do this math here. We divide by 0.5 to find M2 and divide by 0.5. Yep. Yep, very similar to the gas laws where we had like P1 V1 equals P2 V2. Very, very similar. Yeah. Just instead of P, we have molarity here. Okay. So we get, so our M2 should be, so 5 divided by 0.5 is 10. 10 times that is 0.15 molar. So that should be our new molarity. Okay, so very, very simple. Um, that's pretty much what you're going to be dealing with for questions 1 through 5. Very similar. You're just you're given 3 of the variables, M1, V1, M2, V2, 3 of them, and then you need to find out which, um, then solve for the variable you're looking for. Okay. Do remember again, convert milliliters. So all these milliliters, convert those to liters. Okay, just divide by 1,000, or you can move the decimal place over 3 times. Okay. Be careful with number 4. Number 4, you're boiling the water away, so the new volume is actually less. So this one, you're just kind of removing some water by boiling. It's kind of tricky. And then number 5 is a little bit tricky because that's how much water would you need to add to a 500 milliliter solution of 2.4 molar KCl to make a 1 molar solution. Okay, so this is kind of another type of problem. So let's kind of figure out, let's look at that type of problem too. So let's say, okay, so let's say if we have a 5 molar, so we have a 5 molar solution. HCl solution, let's say. How would we make 500 mLs of a 1 molar solution? So we have a 5 molar HCl solution. This highly concentrated solution, we call this high concentrated solution. We call that a stock solution. A stock solution is a solution of high concentration that we use and dilute to make lower concentration solutions. Okay, so you're going to be taking a high concentrated solution, a stock solution, okay, and figuring out how much of it you need to add to make a 500 milliliter solution. Okay, so again, we use M1, we still use M1 V1 equals M2 V2. In this case, our initial molarity is our stock solution, our 5 molar. Okay, we don't know what volume of it we're going to need. If we're going to make a 1 molar solution, and we're going to make 500 milliliters of it, or 0.5 liters. Okay, so basically we divide by 5, divide by 5, we get volume to be 10, right? 0.5 divided by 5, sorry, 0.5 divided by 5 is 0.01, right? Yeah, or sorry, 0.1, not 0.0, yeah, my bad, 0.01. Sorry, not 0.01, 0.1, 0.1 liters. Whew, anyway. So what we need is we need 0.1 liters of the stock solution. Okay, so what we would do is we would take 0.1 liters of the stock solution and we put it into a volumetric flask. So this would be a 500 milliliter, 500 ml, or 0.5 liter volumetric flask. Okay, so we take this 0.1 liters of stock solution, okay, and we put it into this volumetric, okay, and then we would fill the rest of it. We would fill up to 0.5 liters or 500 milliliters with distilled water. Distilled or deionized water, same kind of idea. So essentially, what we're adding is we're adding 400 milliliters of water, or 0.4 liters of water, right? Because we had the 0.1 liters of stock solution, and then we fill it up to the 500 milliliter mark, so we'd actually be adding 400 milliliters of water. Okay, so we have 0.1 liters of stock solution and then 400 milliliters of water, or 0.4 liters of water. Okay, and that's kind of what this question number 5 is asking. Like, you just got to be careful because you're going to find the new volume. You're going to find the volume that you need the total volume that you need to make. You'll find V2, okay, whatever that is. And then you'll just have to say, okay, well, that means that's the total volume we need, but we already started with 500 milliliters, so we have to take away 0.5 liters to figure out how much water we're actually adding. Okay, how many liters of water we're actually adding. Okay, hopefully that makes sense. Okay, for the next problems, very similar to what I just talked about there. Okay, this one though, they're not asking how much water you're adding. They're just asking what volume of concentrated ammonia you're going to need. So this is your M1V1. Actually, M1V1. Your M1V1 will be your concentrated ammonium and your hydrochloric acid. And your M2V2 will actually be these two. And it really doesn't matter which one comes first or second, as long as you group them together correctly. Like M1V1 doesn't have to be this doesn't have to go first. It doesn't matter what order they go in. Okay. Okay. I do have the answers along with some of the work provided. So give those a shot. Try the best you can. Number 5 is very tricky. It's hard. So do the best you can with that. And it's 70% by volume. Okay, 70% by volume, by the way. Actually, let me see. Is it by volume? Look at the answers. It'll help you. Yeah. Yeah. Yep. Okay. So anyway, yeah. Give it a shot. Do the best you can. It's only 10 problems, so make sure you take your time, think through it, struggle a little bit before you look at the answers, okay? Then you can look at the answers, and then I'll give you some more practice for tomorrow. Sound good? Okay, let me stop.